So in today's video, we are going to discuss catchment area method. So what we do in this particular method, we calculate load on a column, and the approach is very simple. Without going into the intricate details of a structure, we can calculate load on a column. So how do we do it? Let's consider this particular example. In this particular example, this plan is given and this elevation is given. So the problem is, or we are supposed to determine load at foundation level. At foundation level, we are supposed to calculate load so that we can design basically the foundation. Now we are supposed to calculate loads in the interior column. So this A is my interior column, this B is my exterior column, and this C is my corner column. So all of these columns, the load on all of these columns can be calculated by considering the catchment area that these columns share. So how can we do this? It's very easy. First of all, if you consider, let's say, column A, the catchment area of this column, this shaded part, as you can see, this shaded part, how can we establish this shaded part? First of all, this distance is 20 feet. And how we establish this 20 feet? The half distance of the neighboring vertical column. So the half distance of this and the half distance between this and this. So the half distance of this. So ultimately, if you add both, then it will be, okay, it zoom out accidentally. Okay, then it will be 20 feet. Similarly, if we consider the half distance of this and the half distance of this distance will be 30 feet, right? So in this fashion, we basically establish the catchment area. So now for column A, the catchment area or let's say AC is basically 20 multiplied by 30. All right, so it will be 600 square feet, or my tablet makes it messy, so it is square feet. So whatever basically in this catchment area lies will be transferred to my column, right? So first of all, if I ask you what kind of things are in this catchment area that I can translate to my column, first of all, I should know that what kind of loads are basically applied. So this is my data provided. So at roof level, the superimposed dead load at roof level is 20 psf. Live load at roof level is 30 psf. Similarly, on other floors apart from roof, the superimposed dead load is 30 psf, while live load is 70 psf. So these are the applied loads. So these applied loads will obviously be transferred to my column, right? So apart from applied load, what else should be transferred? Obviously, the self weight of the slab. And how you will calculate, we will look into it shortly. But this patch or this catchment area, the self weight of the slab shared by this catchment area will be transferred to my column. In addition, if you look closely, there are beams inside this catchment area. So those beams will be considered. These are my primary beams. The length of the primary beams will be considered and the load will be transferred to the column, and the length of the secondary beams will be considered and the load will be transferred to the column. Right. In addition, wall superimposed dead load or the wall self weight will be calculated and transferred. How can we do it? First of all, these walls always be on my primary beams. So these walls are always be on my primary beams, right? So the length of the primary beams are basically the length of the wall. So after establishing the problem and the given data, and apart from these, the given data, if we look into the given data, then the floor height is given. This floor height will be used in walls basically when we are calculating the self weight of the wall. 6 inches slab thickness is given, so the self weight of slab will be considered through this, and the dimensions of the beams are given, so self weight of the beams will be considered through this. Primary length of primary beams are given, length of secondary beams are given, the dimensions of the columns are also given, and obviously the density of concrete and the density of the wall. So now, without wasting time, let's start calculating. So the solution is also, I'm also showing you the solution. This is the solution. This is the Excel sheet or the snapshot of the Excel sheet. So what I have done here, this is the catchment area, 600 square feet, as you have seen before. First of all, let's consider the roof. So how did I get this 45? So first, if I want to calculate the self weight of the roof, if I want to calculate self weight of slab, then it's very easy. I just need to know the volume of the slab and I should multiply it with the density of concrete. So what is the volume of the slab? I have 6 inches as it is provided here. I have 6 inches slab multiplied by catchment area. So you know already this is my catchment area, right? So I can write here 600 square feet, and here I am dividing by 12 so that it can be transferred into feet, and then I multiply. This is my volume. So now you know this is my volume, right? Now I multiply this whole term, this volume, with the density, and the density is already provided to you, 150 pound per cubic feet, right? So when you multiply all of these values, it will be, the answer will be in pounds. So we divide the whole term by 1000 so that the answer in kips, and the answer will be this much, 45 kips, right? Similarly, if we talk about superimposed dead load at the roof level is this 20 psf. So 20 psf multiplied by the catchment area. So we know the catchment area is 600 square feet. So 2612 to multiply, if you multiply 20 with 600, it will be 12,000, and you divide it by 1000 so that it will be in kips, and ultimately this is your answer, 12 kips. Similarly, you do this for live load. So this is your roof live load, 30 multiplied by 600 divided by 1000 equals to 18 kips. Here equals to 12 kips, and here equal to 45 kips. So these numbers are being reflected over here, right? So these numbers are being reflected over here, right? So now you know that how you calculated these numbers, right? For the time being, we are not considering beams for now, but obviously now the next step is the self weight of the beam. So now you have successfully transferred all of the loads from the slab to the beam, or sorry, to the column. So now the next step is to basically consider the self weight of the beam. So now let's discuss that. Let me clean my board and let me clean this overwrites. Yeah, it's more tidy now. So now so the beam self weight, because whatever we have done, we have transferred the load but not the self weight of the beam. So in order to transfer the self weight of the beam, we remember one thing: beam is cast with slab. So the height of the beam includes the thickness of the slab as well. So this is H and this is B. So if while calculating the self weight of the beam, if you consider this whole H, then you are considering the part of the slab which you have already taken place while considering this catchment area, or what do I say, catchment volume, because you have multiplied this catchment area with the thickness and then you multiplied it with the density, so that you calculated the self weight of the slab, right? But now what you have done, you have included a small portion of the beam into the self weight of the slab, right? Because the slab, as I told you, as I have shown you, that the beam, the height of the beam is from the top of the slab till the bottom of the beam. So this is your H, right? So the cross section that you will consider will be H minus T. Let's consider this is T, right? So while calculating the volume, you should consider H minus T multiplied by B multiplied by length of the beam. So this is your volume, right? So now let's calculate the length. Now you already know the length of the beams, the length of the primary beams. So if I recall you the stuff that I have told you just few minutes before, so this is the length of the primary beams. So here this is 10, this is 10, so this is 20, this is 15, this is 15, so this is 30. So length of the primary beam is basically 50 feet. And what about length of the secondary beams? So length of the secondary beams, this is 10, this is 10, 20, 10, 10, 20. So it will be 20 feet. So length of the secondary beam is 20 feet. So if we add these two, it will be 90 feet. So we consider this, the total beam length is basically 90 feet. Now what you will do, you will calculate the self weight, and how you will do, you will obviously 12 inches is the total height of the beam, while 6 inches is the thickness of the beam. So you will consider 12 minus 6, as you have seen here, and obviously divide by 12, multiply by width of the beam 6, divide by 12, length multiply by length, which is this 90, right? And then this is basically your volume. This is your volume, and you multiply this volume obviously with the density, and you know density is 150 pound per cubic feet. So when you multiply all of these terms, ultimately the number you will get after dividing it with 1000 or by 1000, you will get 3.375 kips, and the number is basically over here. Right now, since you are on the roof, so there will be no wall on the primary beam, so therefore the self weight of the wall is 0, and obviously the self weight of the wall is 0, and obviously the self weight of the column is also 0. And why? Because obviously if you are at the roof level, there is no column above the roof, there is no column above the roof, right? So ultimately there is no column above the roof. So if there is no column above the roof, there will be no self-weight on the column, right, of the column, right? So after doing all of this, we have calculated everything about the load, the load which is being transferred from the catchment to the column at roof level. So how much it has been transferred at roof level. We add all of these loads and bingo, this is the answer, right? And similarly, what you do, you go to floor 5 and now you calculate the self weight, which will be the same. You calculate superimposed dead load, which will be different obviously because the values has been updated for the superimposed dead load and live load. So these values will be different. Self weight of the beam will be same. Now there will be self weight of column. And how? Because why? Because there is column at this is your, okay, sorry for, yeah, so this is your floor 1. So at floor 1 there is self weight of this column, which is basically the height of the column is 10 feet, the clear height, right? So what you will do, you calculate it. And how you calculate it? So the self weight of column will be the cross section of the column. So we know 18 by 18, so 18 divided by 12 multiplied by 18 divided by 12 multiplied by the length of the column. So what is the length of the column? 10 feet. So this is your volume, this is your volume, and now you multiply this volume with the density of the concrete, right? So, and you obviously divide this whole term, or let me divide it. You divide this whole term by 1000, and ultimately the value will become 3.375 gives. It's just a coincidence. The value is similar to what we have calculated in beams. It's just a coincidence. It's not always be the same, right? So now wall. So how you calculate for wall? Again, very easy. You know, you need to calculate the basically the volume of the wall. So you can visualize wall. So wall is looks like this. So you need this B. So you already know B, which is the width of the beam. It is 6 inches. You need the length of the wall. So length of the walls are always be on the primary beams, these red ones. Obviously it will not be on secondary beams. So you just calculate the length of the primary beams. We already know 50 feet, and you need height. So the floor height you already given 10 feet. So it will be 10 feet. So you need to calculate the volume. So the self weight of wall will be 6 divided by 12 multiplied by 50 multiplied by 10 multiplied by the density of the wall, right? So density of the wall is given over here, right? So this is your volume, and ultimately this answer, after dividing by 1000, the answer will be 30 kips, and the 30 kips is obviously written here. So you add these values, also you add the previous one to get this value. So this is what we call vertical accumulation. And why? Because obviously the load from the, if we talk about this interior column, the load from the, or if we are at first floor right now, so load from the catchment, the surrounding basically the catchment area will be transferred to this column. Also the baggage which is carried by the roof, so this will be added, right? If we are at second floor, so now, or I call this first floor, I should have called it fifth floor, and then fourth floor. So if you are at fourth floor, then it will be the load transferred to this column plus the baggage from the previous floors, right? So that's how you basically calculate. Or if I give you a more elaborative example, then let's say this is the catchment of the roof and this is your column which is going, then this is the catchment at the 4th floor, then this column is your going, then this is the catchment at the 4th floor, right? The column, and it is going on, right? It is keep going on. So first of all, at roof level we calculate from the catchment to the column, and then at floor 5 then catchment to the column along with this thing on the column, because this is the baggage it is basically carrying, right? The catchment of the previous floor. Similarly, if we are talking about floor 4, the catchment to the column and plus the previous catchment load will be transferred to this column. So in short, if you look here in this particular table, let me again clean it so that I can rewrite. So what I do, that this thing will be sum and this number will come, this thing will be sum plus this, and this number will come. Then floor 4, now the loads are same all over. So this thing will be sum plus this column, then this plus now this plus this plus. Now if you add the footing level, you observe that this is 0, this is 0, this is 0, this is 0, this is 0. However, the column load is not 0. What is happening over here? So try to understand. At the first floor, okay, or this is basically the ground floor, or if you say so at this floor level, the load will be transferred to the column, right? The load from this particular floor will be transferred to the column. But at footing, is there any floor? No. So there will be no load on the, obviously at footing we are not going to basically, it's like everyone can comprehend this, that at footing level there will be no load. What do I mean by no load? That there will be no floor, there is no floor, the catchment of the floor through which the load will be transferred. So the slab, the applied load is 0, the self weight of the slab is 0, obviously. Beam, there at footing levels, it's the footing. Why should we have slab or beams at the footing level? So the only thing is column, and obviously there will be no wall, the column. The height of the column, obviously the height of the column will be the load due to the height of the column will be transferred to the footing, right? So now I hope that you have understood the mechanism of catchment area, and if you have any question you can leave your comments and I will try to answer each of them. Till the next video, goodbye.